Okay, this looks like a familiar problem though. The longest contiguous subarray with absolute diff less than or equal to limit. Okay, so given an array of integers norms and an integer limit, return the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to the limit. Okay. So let's see the example. 8247. The limit is 4. So all the subarrays, we got all the subarrays 8, 82, 824, 8247, 2, 24, 247, 4, 7, 4, 7. Okay. So we got all the subarrays and we found what is the absolute difference. Okay, and got all the subarrays and found the absolute difference. Let's see what are valid. Smaller or equal to, smaller or equal to. Okay, found 2 is 1. Okay, let's say from all the subarrays that satisfy the requirement, longest one is 2. Okay, I got this. So my intuition is that I'm going to use sliding window for these problems, and I'm going to expand the window and I'm just going to expand the window whenever the satisfy the requirement, and if in some case it does not satisfy the requirement, it will shrink until it satisfies. And every time after I got the valid window, I will just update the length and see what is correct. And also the thing to tell whether this window is satisfied, since we need to get the absolute difference less or equal to the limit, I think the key point is that we need to find the max and minimum. What is the efficient way to find the max and minimum of a subarray? Brute force is absolutely a way to do this. Brute force absolutely a way to do this. But this could be quite efficient. I'm thinking about using 2deque, right? Using 2deque. One is monolithic, increasing one. One is a decreasing one, and the decreasing one to find the max, and the increasing one to find the minimum. Yeah, and by maintaining that, we just get a minimum maximum of the subarray very efficiently, and then we get the difference between them, and we got whether it is valid or not. Yeah, that's the basic idea. I think I can code it up. So the min deque, it's got the this is the minimum deque. We got the maximum deque. Okay. Got this, and we initialize that pointer. Start the sliding window algorithm. Okay, the right integer is So we try to put it in the deck in a proper way. For the max deck, we will check so the max deck should be supposed to have a decreasing monolithic deck, decreasing monotonic. We can have a decreasing one. So if the max deck exists and max deck management smaller than the current one. Okay, we use the deck to store the indices. For this one, that means we need to pop and at the same time we pop onto it maintains the decreasing monolithic deck, and then we add it there. Append. Okay, so that's how we maintain the max and min, and let me think. And for the main deck, we also need to maintain this. So for the main deck, we are going to just make sure that it is increasing, as we always wanted to get the smallest one. So similarly, if it is larger, then if the end of the deck's value is larger than the new right one, then new right integer, that means it's larger, so it cannot keep increasing. We pop until it's enticed by. Okay. Main deque append. Right. Okay. So in this case, we have found the max main, and what we are going to do is we wanted to find what is the absolute value of the max main. So the max would be just a deque, max deque, just a max deque 0. Min is main deque 0. Compared. We got the absolute value and check if it is smaller, if it's larger than the limit. If it is larger than the limit, that means we need to make sure we need to shrink. We need to shrink. So how to shrink? When we shrink, we also need to make sure that we are updating our deque accordingly. So what is the right integer? Oh, the left integer is okay. Left integer is this. Let me think. So this is the left integer. We wanted to make sure first. Let's check is but we move the. So we need to make sure that this is not the max. This is not the max value. So if this is the max. Okay, that means we need to take actions to update the max deque as well. Pop left. Okay. And if this equal to the main deque, then we need to pop left as well. Okay, so in this way we updated our Subarray and updated the max main as well. After this value, we are sure that we have got the valid one. Since we want the longest, we check best equals max. Okay, after this, every time we update this, and at last we are going to return best. Okay, I think that what is happening here? Let's see why. Okay, out of bound. Let me think how to do this. So when we shrink, we could, okay, it is possible that, okay, let me think why this happens. Okay, for this one, as long as they actually so let me think how to do this. We just run the limit to less than or equal to, I think I'm going to quickly trace what is happening here. What is this? I wanted to make sure that the way we got the absolute value is alright. Absolute difference. Okay, how to this, should I add this absolute? Okay, wrong answer. Why? Oh my. Oh no. Oh wait, I think there's some problem with the, oh, okay, I think I know why, cause this is not right, because I am going to compare the value, so it should be, oh wait, let me think. Okay. So this is, I need to keep in mind that what I store is not the value, it is the index. So let me edit. This is the problem. Okay, this is one place there's a problem. Okay, I should also compare this with the value itself rather than the index. Quickly fix this. Let me quickly fix this. Okay, this time it could work. Okay, awesome, works.